Hello, my name is Avereigh Barras. I'm in Engineering Materials 201, Section 1. In this video, I'm going to talk about the importance of tempering, specifically in the heat treatment process of automobile pistons. To start off, pistons are a critical part of driving a car. They convert thermal energy into mechanical energy that vehicles rely on to operate properly. However, there are specific requirements the pistons must meet in order to successfully fulfill their role, including several mechanical properties. For example, it must be strong, yet relatively ductile, since it will experience a lot of friction. And it must be able to operate at high temperatures without expanding too much. These are just a couple of conditions the material must satisfy. Therefore, the carbon steel the piston is made of must undergo a specific heat treatment process to ensure the desired results are attained. The heat treatment process begins with heating to an austenizing temperature, that is, above the euductoid temperature, which is 727 degrees Celsius. Next, it is rapidly quenched to room temperature. Then, it is reheated to a temperature between 816 degrees Celsius to 871 degrees Celsius in this case. Then it's held at that temperature for some time before being cooled back down to room temperature. I want to expand on the importance of steps 3 and 4 as they are part of the processing known as tempering. If we were to stop the heat treatment process before tempering, we would get 100% martensite, as shown on the left. I would like to contrast it with spheroidite, a microstructure with the opposite resulting mechanical properties. It is clear in these illustrations that martensite has a needle-like pattern, while spheroidite has spherical grains. The rounder the grains, the more mobility the particles have, so spheroidite has a considerably higher ductility. On the other hand, martensite is very strong yet very brittle. Ultimately, martensite is not tough enough, while spheroidite is not strong enough for an application like a piston. So we need to find a happy medium, which is where tempering comes in and saves the day. Here is tempered martensite. It looks like the grains are rounder instead of needle-like, right? That's because the reheating of the material after quenching allowed for more carbon atoms to diffuse and relieve internal stress. The grains are then able to settle in a stable, orderly fashion. Now the material has both the strength and ductility we were looking for, as well as the other mechanical properties needed to satisfy the requirements for pistons. The microstructure tempered martensite is necessary for automobile pistons, along with many other everyday uses. At the end of the day, tempering helps achieve our goal of altering the mechanical properties of our material in order to fulfill a specific need. If it weren't for heat treating and tempering, our material wouldn't be able to fulfill its vital role in the automobile industry. So I hope this video has explained the importance of tempering, specifically with pistons and automobiles. Thank you for watching.